So, you've probably heard the term AI thrown around a lot lately. It's in your phone, it's in your car, it's in the news. It's basically everywhere. And with all that buzz, a whole bunch of other acronyms have started popping up. AGI, ASI, ANI. It's easy to get them all mixed up, or just lump them together under the big umbrella of AI. But here's the thing. They're not the same, not even close. Understanding the differences between them is actually super important for getting a clear picture of where technology is today, and more importantly, where it might be headed. So, that's what we're going to do today. We're breaking down the differences between AI, AGI, ASI, and ANI. We'll cut through the jargon and get straight to what each of these terms really means. Think of this as your definitive guide to the AI landscape. We'll look at what's powering the apps you use every day, what scientists are working towards in labs, and what still lives purely in the realm of science fiction. It's a fascinating spectrum of technology, and the distinctions are pretty key. By the end of this video, you'll be able to tell your ANIs from your AGIs with confidence. You'll understand why your smart assistant can play a song, but can't write a novel, and what it would take for that to change. It's less about a tech deep dive, and more about building a solid foundation of knowledge, because honestly, this stuff is only going to become more relevant over time. So, let's get into it. Alright, so let's start with the big one, the term that covers everything else. Artificial intelligence, or AI. At its core, AI is a massive, super broad field of computer science. The whole goal is to create machines or software that can perform tasks that normally require human intelligence. This includes things like learning from experience, recognizing patterns, understanding language, making decisions, and solving problems. It's not one single thing. It's a huge collection of different technologies and methods. Think about it like the term sports. Saying you're into sports could mean anything from basketball to swimming to chess. In the same way, saying something uses AI is just the starting point. It could be using machine learning, deep learning, natural language processing, or computer vision. These are all subfields of AI. The key takeaway here is that AI is the overarching concept of making machines smart in some capacity, even if that smart is very, very specific. So when you see AI in the real world, it's almost always a specific application. That photo app on your phone that automatically sorts pictures of your dog, that's AI, specifically computer vision. When you get a recommendation for a new show to watch on a streaming service, that's AI, using a recommendation algorithm. Even the spam filter in your email is a form of AI, learning to identify what's junk and what's important. The common thread is that these systems are designed to perceive their environment and take actions to maximize their chance of successfully achieving some goal. They aren't just following a rigid set of pre-programmed instructions like old-school software. Instead, they can adapt and learn based on the data they're given. And that ability to learn is what really separates modern AI from simple automation. But as we'll see, the way they learn and the scope of what they can do is where the other acronyms come into play. Okay, now let's talk about the one you see in a lot of movies, the holy grail, for a lot of AI researchers, artificial general intelligence, or AGI. This is a huge leap from what we just discussed. While standard AI is great at specific tasks, AGI is the idea of a machine that has the ability to understand, learn, and apply its intelligence to solve any problem, much like a human being. It's not just about being good at one thing, it's about having broad, flexible, and adaptable cognitive abilities. So, an AGI wouldn't need to be specially trained to play chess, then retrained to write a poem, and then retrained again to translate a language. It would have the underlying general intelligence to figure out how to do all of those things on its own, just by learning the rules and context, similar to how a person could. It could reason, think abstractly, understand complex ideas, and learn from experience across a wide variety of domains without needing a complete software overhaul for each new task. This is where the line gets a little blurry, because as of right now, true AGI does not exist. We're still firmly in the world of specialized AI. We have systems that can beat the world's best Go players and systems that can generate incredible art, but we don't have a single system that can do both and then also learn to cook dinner. Creating AGI is an incredibly complex challenge. It involves not just raw processing power, but cracking the code of things like common sense, consciousness, and genuine understanding. Researchers are working on it, of course. They're exploring different approaches, from trying to build larger and more complex neural networks to trying to reverse engineer the human brain. But we're not there yet. So, whenever you hear about a new AI model that seems incredibly smart, it's important to remember that it's still operating within a specific, albeit sometimes very large, set of parameters. AGI represents the theoretical point where that limitation disappears. Now, if AGI is the holy grail, then artificial superintelligence, or SI, is what lies beyond it. This is where things get really theoretical, and for some, a little bit scary. ASI is defined as an intellect that is much smarter than the best human brains in practically every field. This isn't just about being faster at calculations, it's about having a level of intelligence, including scientific creativity, general wisdom, and social skills, that is qualitatively superior to any human. Think about the gap in intelligence between a human and, say, an ant. An ant can do some complex things, like build colonies and find food, but it can't even begin to comprehend the concepts of astrophysics, philosophy, or even what a smartphone is. The theory behind ASI is that the gap between an ASI and a human could be just as vast or even greater. It would be an entity that could solve problems that humanity has been stuck on for centuries in a matter of minutes or seconds. This is, of course, purely hypothetical. We haven't even achieved AGI, so ASI is still a step or two beyond that. The path to ASI would likely involve an AGI that has the ability to recursively improve itself. An AI that is as smart as a human could, in theory, design an AI that is even smarter. That smarter AI could then design an even smarter one, and so on, leading to a rapid, exponential intelligence explosion that could leave human intelligence far, far behind. This is the concept that sparks a lot of debate among futurists, philosophers, and scientists like Nick Bostrom and the late Stephen Hawking. The discussions revolve around the immense potential benefits, like curing all diseases or solving climate change, and the profound existential risks of creating something so far beyond our own comprehension and control. For now, ASI remains firmly in the realm of science fiction and philosophical debate, but it's the logical, albeit extreme, endpoint of the AI development trajectory. Alright, so we've been to the far reaches of science fiction with ASI. Now let's bring it all the way back to reality, to the AI that you and I interact with every single day. This is artificial narrow intelligence, or ANI. Sometimes it's also called weak AI, but I think narrow is a much better description. ANI is AI that is designed and trained to perform one specific task or a very limited set of related tasks. It operates within a predefined narrow range. This is, by a huge margin, the most common and currently the only form of AI that exists in the world. Every single AI application you can think of right now falls under this category. The AI that plays chess? It's an ANI. It can't drive a car. The AI in a self-driving car? Also an ANI. It can't check your email for spam. Siri, Alexa, Google Assistant, these are all advanced examples of ANI. They can answer a wide range of questions, but they aren't truly thinking or understanding in a general sense. Their intelligence is like a mile deep, but only an inch wide. A chess-playing AI can analyze more moves per second than any human grandmaster, making it superhuman in that one specific context. But if you were to ask that same AI for its opinion on the weather, or what it wants for lunch, it would have no idea what you're talking about. It doesn't have consciousness, self-awareness, or genuine understanding. It's a highly sophisticated pattern-matching machine. So when you see headlines about AI achieving some new milestone, it's almost certain they're talking about a new achievement in ANI. These systems are incredibly powerful and useful, and they're getting more capable all the time. They're transforming industries from healthcare to finance to entertainment. But it's crucial to remember their limitations. They are tools, highly specialized tools, and that's the key difference between the AI of today and the AGI or ASI of tomorrow. So there you have it, a breakdown of the AI alphabet soup. At the end of the day, it's pretty straightforward. ANI is the specialized AI we have today. AGI is the human-level AI we're working towards. And ASI is the theoretical superintelligent AI that's beyond human. From the narrow and practical to the general and theoretical, each term represents a fundamentally different level of machine intelligence and capability. It's a spectrum, and right now we're firmly at the beginning of it. But it's a space that's moving incredibly fast. Understanding these distinctions is more than just tech trivia. It helps you cut through the hype and have a more informed conversation about what these technologies can and can't do. It gives you context for the next big AI breakthrough you read about, and helps you appreciate both the power of the tools we have now and the scale of the challenge in building the machines of the future. The journey from narrow intelligence to general and beyond is one of the most exciting stories in technology today. But I'm curious to hear your thoughts. Now that you have the breakdown, which type of AI do you find the most interesting? Or maybe even the most concerning? Is it the practical applications of ANI, the human-like potential of AGI, or the mind-bending possibilities of ASI? Let me know down in the comments below. It's always interesting to see where everyone's head is at with this stuff. Thanks for watching, and I'll catch you in the next one.